It's time for STEM with Cog. Look, Cog, look. Let's talk about natural gas. You know, the fossil fuel kind of gas made of ancient plankton. Well, since it's come up, let's look at flatulence first. In humans, it is only about 7% methane. On the other hand, the fossil fuel natural gas we burn is 85 to 95% methane. So when we're talking about natural gas, we're pretty much talking about methane. Whatever you call it, it catches fire easily. Maybe you've seen those blue flames on gas stove burners. Here's what's happening. CH4 methane plus two O2's oxygens produces carbon dioxide plus two H2O's water plus heat and light. But where did that methane gas come from? The simple answer is it came from underground, where natural gas and crude oil formed from ancient plankton that died 300 to 65 million years ago. In porous rock, the gas travels through the connected spaces and can form a reservoir. It's relatively easy to drill down to get that gas, but a lot of that easy-to-get gas has already been got. It's harder to get natural gas or oil from less porous rock like shale. This sedimentary rock has fewer connected spaces for the oil to travel through. To get that gas, we frack. Fracking is controversial, so I've put links in the video description if you want to learn more about the debate. Fracking is a bit like this. The bottle full of gelatin represents a layer of shale. The straw and vet catheter represent drilling equipment. Instead of water, sand, and chemicals, my fracking fluid is plaster of Paris. To frack, you gotta drill horizontally through the rock and insert the well casing. Now it's time to pump fracking fluid into the rock at high pressure. If I were really fracking, I'd use a specialized gun to create small holes in the casing and into the rock. I've only got one hole, and it's in the catheter. Time to frack. Not like that. Oh. Arg! Well, at least now you can kind of see how a fracking mixture can crack the rock open. A fracking operation would then pump the water and some chemicals out, leaving behind some chemicals and the sand to keep cracks open so the gas or oil can flow through the spaces in the sand into the well casing to be pumped up. The gas then travels through pipes, is cleaned, and processed. Because methane is invisible and odorless, the gas company adds an odorant to let you know if you have a leak. Some homes and buildings are heated by burning natural gas. We can also burn gas to heat our water and cook our food. We can burn natural gas to produce heat that's necessary to make paper, glass, bricks, steel, and iron. It's also used as a building block to make fertilizer and plastics. More and more, we burn natural gas to make electricity. You might want to go back to episode 4 on coal to review how magnets and copper wires are used to generate electricity. Before this explanation of gas-fired plants. Most gas-fired power plants work like this. Air is compressed, causing it to heat up. Methane is added and pow! Combustion produces heated carbon dioxide and water vapor. Those hot gases rush over a turbine, spinning a generator to make electricity. Globally, in 2021, we produced 7.92, almost 8 billion tons of carbon dioxide by burning natural gas. The big kickoff for releasing excess carbon into our atmosphere came with the Industrial Revolution, about in the 1850s. That carbon came from ancient buried coal. It was available. You can mine it with some simple equipment and your hands. That makes it cheap. Developing nations today are building their first power plants, and many of them burn coal for the same reasons. Around the 1950s, we started drilling for oil and gas. Today, developed countries can afford to replace coal-fired power plants with gas-fired plants. Methane burns much cleaner. This graph shows how much CO2 is produced per year. That graph shows how much CO2 is produced per unit of heat. You can see natural gas produces about half as much carbon dioxide as coal per unit of heat. But natural gas has drawbacks too. Because it's odorless and invisible, it can leak into the atmosphere and trap heat. Let's go down that rabbit hole and talk about maverick methane. I'm calling all the methane released into the atmosphere maverick methane because it's wild and free, just like the song. Maverick is the name, wild as the wind in Oregon, blowing up a canyon, easier to tame. But I digress. Maverick methane is a very powerful greenhouse gas. When it's leaked, methane traps about 80 times more heat from the sun than CO2, pound for pound. That's a big problem. Although it's true that after a few decades, methane reacts with oxygen in the atmosphere to become carbon dioxide and water, then it becomes part of our carbon dioxide problem. Still, over 100 years, adding 1 ton of methane has the same heating effect as adding 25 tons of CO2. And methane levels are rising since the Industrial Revolution, along with carbon dioxide levels. Because there's 220 times more CO2 than methane in our atmosphere, it seems like a bigger problem. But in the short term, reducing maverick methane can really help us attack climate change. But where does it come from? Some of it comes from microbes called methanogens, which break down poop and debris in mud or underwater, places without oxygen. These microbes turn waste into a lot of methane. If the methane bubbles up from a swamp, it's part of an ecosystem. No worries. But if the methane rises out of human poop and digesters at a sewage plant, or from a slurry pit or lagoon full of cattle waste, it's called anthropogenic methane. Anthropogenic means the methane was released because of human activity. About 60% of our maverick methane released today is anthropogenic. We now have satellites and mobile labs that can pinpoint anthropogenic emissions. If only we could get in on those communications. Oh, Caw, look at you. You're an anthropogenic maverick methane wrangler.
Who doggy?
You've got a lead. It's a gas-fired power plant. Send out the alert. We need engineers and plumbers to fix all the leaky pipes and valves. All of them. All the way back to and including the drilling site.
Who doggy?
You've got another lead. Oh no, it's an orphan well. A long time ago, this well was abandoned. Somebody just cut the pipe, put a rock on top, and rode off into the sunset. It's been spewing methane for decades. We need construction workers to cap that well.
Who doggy?
What has the satellite found now? Cows? Like real mavericks? Well, I guess you better find out which end the methane is coming out. Mostly from the burps. Call in the ranchers and the scientists. We can't stop cow burps, but maybe we can reduce the methane by changing their diet. Or ours.
Who doggy?
Another lead. A garbage dump. All that wasted food is rotting without oxygen. Call in the troops. Wait a minute. What troops? Oh, you mean me? Well, you're right. We can all stop wasting so much food. We know now where the methane is coming from. Anthropogenic methane comes from fossil fuels, agriculture, and waste. But here's the thing. Since it's coming from human activities, that means different human activities can fix it. We've got the technology and the ability to lasso up a lot of that anthropogenic maverick methane. So let's just pay the money and get her done. Time to recap. Natural gas or methane can be produced by ancient plankton. We can extract it by drilling or fracking. We burn methane to heat buildings, produce industrial materials, and make electricity. In 2021, we produced about 8 billion tons of CO2 by burning natural gas. We have the technology to find and reduce anthropogenic methane we release. So far, We've discussed 5 CO2 sources that we have some control over. But there's another source of CO2 that we really can't control. I think you're going to get a bang out of